Okay. So I'm gonna make this all the videos available for you. If you by any chance, if you miss anything, then in that you're not gonna miss any classes, contents, discussion, material, theory, programming, nothing. Okay. So on the other hand, by any chance that you cannot that access even those videos, that you can just schedule like a one-on-one that help session, then I'm more than happy to help you guys. So much help is already that available for you guys to be very successful at the end of this course. That's our target. Okay. So what I meant by that, the continuation of that 620, in 620, you can remember we were dealing with the continuous data. Now, continuous data, on top of the continuous data, mainly that the classification of the variable. When it comes to classification of variables, in statistics, we're going to do so many that sub-classification. But in data science, we mainly have two types of variables. One is categorical, the other one categorical or qualitative or string. The other one is quantitative or numerical or continuous. Sometimes we call continuous. Okay. So major two branches. Then the continuous part we tackle in that 620 and 620. So in that one that we mainly covered regression. Here we're going to go to it's some kind of another approach called the contingency tables. Let's look at that, why we're going to have to look at build up such kind of a contingency table here. Before that one, let's have a look at our syllabus a little bit. Okay, I'm going to go ahead and share the other screen. Okay. So there are, see, you have all the, see, you can download that from that links on the Brightspace course readings. Okay. In addition to that one, there are supplemental reading from this Ellen Agresti. I think Agresti is like somebody that who contributed in large scale even for the non-parametrics in statistical arena. Then this book, see? And software SAS Studio on demand. This used to call it that University Edition. Now it's called the on demand since I think the last September.
I do have a quick question on the SAS.
Yeah, go ahead. Go ahead. Yeah.
Are we gonna be using the SAS for academics? Are you gonna be wanting to see our code or just the results of our code?
I think let's do like this way. I like to have like a codes plus the results. I think let's have that discussion later on, because it's a good question, because sometimes the code not going to be enough, but if you let's say code might be enough that sometimes, but for some questions that if it's come along with the codes and then right next to that one the answer being provided, that's going to be easy for me to when I'm doing the grading. But it's not a big deal. But if you find that you don't have that much time to do both of them, then either way is fine. Okay, either way is fine. Just give me the results or just send me the code, but still you are in a good shape. Okay.
Okay.
But I prefer if you can provide both of them. But any chance that if you cannot provide under any circumstance, still they are okay, they are good. So
okay,
either one
you.
of them. Okay. Okay. Yeah. So and this is that mainly see application of method analyzing the categorical data for see. So that's the major part. That's a counterpart of that this guy that prerequisite. Let me have a. I don't see the prerequisite on this one. Did I miss that one? Look. I don't know this the template that they sent to me, but the prerequisite should be that, yeah, I had to correct this one when I just saw this one. Prerequisite should be ANA 620 for in order to get into this class, because that's a continuation of the other class. So material Karthik course also introduce the following program. Those are this one. This is how we're going to have the classes and these days. Okay. And Wednesday, especially that I'm planning to go through the homework with you. Okay, I'm gonna do the homework with you. Okay, so in that way you can just have a look at it. You can get this done ahead of the time, or that just wait until I'm gonna go through that one, get the knowledge from that one, add your version to that one, and make it a nicer answer script and then send to me like that. So pretty much during this office hours tomorrow that I'm planning to go through this the homework. Okay, we have a homework. We have a in-class some assignment as well. Okay, so these are we don't have that much time, not that much that many days, only a few days. That a lot of material being condensed and then within this short period, and a lot of reading. See, a lot of reading. I hope that you are pretty much familiar with this basic statistical concept, practical aspect, probability, hypothesis testing, type 1, type 2 errors. It's this one later to get to here. Okay, so, and then from this textbook, see, biostatistics for medical and biomedical practitioners. From that book that you have to read this chapter 14, SAS categorical data analysis. From that one, 1.1, 1.2, Duffy Dino lectures on CDA. See, the categorical data analysis, chapters 1 through 5. Then you have a homework one and a progress check. But as of now, you don't see that one, but I can make that one available. If I go to, I'm gonna do, see, you can see actually, see, week 1 assignment, okay? I'm gonna make this one available for you and progress check 1 too, okay? Then you can see on your side what you're gonna have for the assignment, what you're gonna have for that progress check 1. Especially that the syllabus, this is the part that I want to bring to you, that it's going to continue for the whole 4 weeks in a similar fashion. And mainly that how you're going to get the grades. See? Homework, 100 points for week 1 homework. Later on, there are another 2 homework for the week 2 and week 3, 150 points for each. So 300 plus this one, 400. Progress check. See, you get the 200 so 200 because each one has like a 50 point for each week. And the project, you have to do a project at the end of the day. Class presentation 100, and you have to write the report. You have to write the report. When you're going to write the report, there are templates. If you're using PDF, sometimes that instead of PDF, if you're familiar with, you can go to LaTeX, make it like a more professional. See, this is LaTeX. If you do on LaTeX, even you're going to go ahead and then see compile, it's going to be converted into PDF over here. Plus that you can get even the presentation rather than having like a PowerPoint presentation, you can get the Beamer. Beamer is the nowadays that we are using as a like a substitute for PowerPoint presentation. So this one using as a like a replacement for the Microsoft Word, see, LaTeX. So if you want, I can show you one of the something that we nowadays we write the article, journal article, even the curriculum vitae, CV, resume, everything can be built up on the LaTeX. Okay. If anybody is interested in that one, when time comes that I can show you at the same time, I'm going to show you like some kind of a research paper for you to get a idea. You don't have to do in like a heavy research papers, but if you do on this one, how that can be done. Okay, I'm gonna give me 1 second. Research, Youden index, multivariate, Youden.
Hi, Professor.
Hey, how are you?
I'm good, thank you. There's someone waiting in the waiting room.
Oh, I'm sorry. I'm sorry.
Yeah.
Oh, wait. Thanks for reminder. Let me see where is the waiting room.
Get him, McCready. Get him.
Okay. Why I cannot see the waiting room? Do I have to get out of this? Okay, share. Then I can see. Yeah, I think that's okay. Sorry. Okay, now I'm gonna share. Sorry about that.
Oh, there's Phil. I was wondering when you were going to show up.
Yeah, I was waiting in the waiting room for like
Waiting room.
forever.
Okay, you were admitted. Don't worry.
We told him not to let you in. We were like, oh, you don't want
No.
to deal with that guy.
I'm so sorry because that I'm so much into this lecture. I completely forget that somebody's waiting over there.
Yeah, no worries. Thank you for letting me in.
Next time I'm gonna make sure because of, okay. Sorry about that. Okay, what I'm trying to show over here. Get it real quick. No, student index, multivariate, student. See, come with the legacy. This is like a kind of like a template. On the template, that when I give the template on top of that one, you can just I can compile here. See? Then you compile, you're gonna get the PDF over here. Very nicely structured PDF. See, it's created. See, this is the abstract part. This one. This is some kind of a research paper now I'm doing with one of my colleagues. Actually, he's my
What platform is this?
This is called the LaTeX. See here,
Okay.
tech file. This is a tech file. But I'm trying to say that when it comes to the project, if you can get this done like this, you can easily, by changing here from article to Beamer, you can even get the presentation. See here, you can see. See, American Mathematical Statistics. See, sorry, American Mathematical Association. See that the one kind of a like a some kind of a like a document class. You can change that one to be. See, this is the introduction. See, theory built up. See, we are not expecting like like this heavy like this, but what I'm trying to say, even the equation numbers.
I like this a lot. Yeah.
Yeah. See, then you can build up everything easily. See. Here you write the code over here. Like let's say you want to write the gamma, then you're gonna write the gamma code little bit, because it's a programming. It's good for you guys to like get familiar with some kind of a more programming. In that way, it's gonna be useful for all the time, rather than working with something like the very basic stuff like the Word very primitive and very basic nowadays compared to what we have at these kind of facilities. See? We built in up everything. And see. You can make that nice tables. See? See? Tables. See? See? Conclusions, reference, references, nicely laid out like that. See? When you if you want, you can make anything that clickable. When you click, see, it's going to go straight to the data set. See? Straight go to data set, but when you're going to send to some kind of a journal, it's easy for them to click on that one and get a clear idea right away, like that. So see, even that this institute and everything, if you want, see, you can make it clickable. See, you write on this side, see. But these, most of them are on a templates. If you go to Overleaf, there's a website Overleaf, that one has like a template for any kind of for posters. You can make a research papers, a presentation, anything can be done at the same time. See? Like that. On top of that one, I'll show you even that presentation part. When it's come to the presentation part, I can show you something very real quick. Let's see. See, that's the presentation that has been developed by that same LaTeX. See? LaTeX, but this is now like a presentation. See? Yeah, you go ahead and MikTeX. Install MikTeX, MikTeX. First, you install MikTeX. Okay. On top of that one, you're gonna install that. Later on, you need the platform to work on that one. Then go to the TechMaker. This is a TechMaker. I'm working on the TechMaker. This is a TechMaker. Any platform. In addition to this one, something called this is an IDE. Same like in a SAS, you work on the SAS Studio. You basic stack SAS you have in R. You install R first, and then on top of that one, in order to work on that one with an interactive, environment IDs. You can use like a R Studio, SAS Studio. Same way TechMaker. First install MikTeX, MikTeX install, and later on install TechMaker. Then find a template and work on that one. See, so even that one. See, that same talk. See, that's the for the talk. See, Beamer. Here you have to change the document class. That's it. See, you can build up that one too. So the same thing that you saw earlier. That see, this one. See, you have so many that. See, same thing that you're gonna you write for the paper can be that diverted into that this presentation as well, and do some kind of editing and then keep whatever you really need for the paper. That this one I kept like a 27 slides. The rest I cut off, like keep the summary like that. See?
Can you type in the chat the name of the platform?
Oh, I'm sorry. I type. Okay.
Someone already put it in there, man.
MikTeX. Install MikTeX.
Okay, I see it.
Install TechMaker. Like that. So that's going to be very useful down the road, even when you do that capstone. Because right now that I'm mentoring for 2 students for National University, but that's the same thing I told them rather than doing with the Word, because I'm planning to get their capstone project being published in some kind of a reputed journal. If you want to do that one, you cannot send by the Word. You have to have that one in this format. Otherwise, it's not acceptable. So since you guys are very familiar with the programming, it's better off to get used to this one too. There's not that much of programming involved with that one, but you have a templates and get used to that one. And then when we working on that one, you can improve your skills on that one as well. Okay. This paper is a very heavily rigorous paper, but this is a biomedical research paper too, something that you guys talking about. Then now it is related to actually that discussion too, because it's a categorical data too. But anyhow, that's I really wanted that bring to your notice this one. Okay. Let me get rid of that one. Let's get back to our syllabus a little bit. I'm gonna get rid of this one. See, when you do the presentation using that click in this one, go one by one, and you can present nicely. See? You can do any editing or anything like that. No, close current one. See, so mainly that this cross project and progress checks and homework. Those are the main thing that we have to do in the class. But we have a lot of readings and then some kind of a material, the theory behind that one. You should have to absorb that one to go through those things. And let's try to build up this one piece by piece. Okay, these are the major ones. And in addition to that one, you have that discussion for the discussion. That's for on your that practice, because we don't give the no points are allocated for the discussion. Okay, you see there's a part for discussion. If you want, go ahead and do that one. If you don't want, just it's not a big deal. Okay.
Just to confirm, you're not requiring us to do discussions. That's what you're saying?
Oh no, because it's not, because of that we don't have any category for that grading category for the discussion. That's the reason. See.
Okay, that's fine. I'm just confirming.
We don't, yeah, see, we don't have. So I'm sorry. There's another one. See. So because of that, mainly let's focus on our homework and project progress check and then project. See, at the end of the day, everybody gonna in a good shape. Okay. If you have any difficulty with any theory, any programming, anything, just let me know. But as of now, I know that you guys are thoroughly familiar with the R, SAS, and both, because you start with the 600, 605, then 620, 615, 620, 75, like that. But even that, if you're not that comfortable with the programming or theory, anything like that, don't worry about that one. What I meant by the theory, we have a lot of, we have to understand one thing in data science. Data science is the application of statistics. Statistics is the application of mathematics. They are connected. So the data science, we have a very nice thing. That means that we don't have to plug in any values into any formula to get our answers. The machine is doing that one. The robot, machine, program is doing that one for us. That's why for all the formula that we're going to see, we're going to call them in data science the process. You see the process and you get a rough idea. Let's say you want to find the confidence interval. You get a rough idea about the confidence interval formula. And you want to find an estimate. You get a rough idea about the estimate. That's more than enough. But then you're going to find the appropriate code to invoke that kind of the statistical procedure. The program will do that one, and the program or the machine or the robot will do that one. So you don't have to worry about anything on that side. Okay, but while we are going through everything, you have to have a clear idea about what's going on, why we are doing this kind of a thing. Okay, because you have to, at the end of the day, being a data scientist, if you want to become an elite data scientist, you have to have a clear-cut knowledge on statistics, data science, and machine learning. Those three very important. These three you do all the data analytics at the end of the day. You cannot discard a statistics. Statistics, that's a platform on which you're working on. Every theory that you see over here, statistical theory, procedures, and methodologies. Okay. So if you're not that much familiar, that's okay. Just get familiarized with that one while we are going through this course. Okay. And that's it. That let's see what we have over here. Okay. Before we get into any of these, I would like to have a look at it, why we are using this contingency table. That discussion we have to build up over here. Okay. So I'm gonna use this one.
Professor, just really quickly, I don't know if you went over this already. I missed the first 10 minutes. I wasn't able to download a fault the slides, and I wasn't able to download the medical data. Was I the only one? The 2010 BR.
The data, no, the data. You're talking about the major data, no?
Yes, I was not able to download.
Yeah, because
they got flagged.
Go ahead and open that one with the Okay, let's go to that one. Go ahead and open with this one. Okay, I'm gonna open that on Firefox.
Oh, so download with Firefox?
Yeah, use a Firefox, because the other one, the other browsers, they don't, that one cannot download from the other browsers. I tried that one with even the Edge, it worked. I tried with the Firefox, it worked. So let's have a look at it, that one real quick. Since you are already mentioned about that one, it's related to, I think I'm gonna go back to this one. Is the no, here it should be here somewhere. Oh no, it should be here. Don't see that. Okay, here. I'm sorry. Here, this is the one. Case study. You're talking about this way? No. Yeah. Briefs data. Okay, go to that website. Behavioral risk factors. See. Here. Go to survey and data documentation. Then go to annual survey data. In 2010, you can download even that code book and then go to the data transport format. See, save file. See, save in here. See. And then you can unzip that one. See, it's in the download. extract. I'm sorry. See, it's already in a see, extract all, and then put it back into that place. So wherever you want that save. See, it's zipped already. You have to unzip. So I'm gonna go ahead and then put at the same place. See, I'm say where you want to save. I save in like one of my folders. So extract, and I'm gonna put it in the same place. See? Unzip now. See? I have a zip one and unzip one both. See? Unzip that. This is the one you can import into SAS Studio. And the SAS Studio, we have another issue too, that this okay. So let's go ahead and little bit open the SAS Studio. Microsoft Edge. Since I have already saved that link over here, see, SAS on demand for academics. Okay. So I mean, like you have to sign in for the login for this one, see, SAS Studio.
The reason I'm asking if you needed the code is because we've got the SAS on demand, and then we've also got the SAS Enterprise Studio, which basically you just click and drag what you want the SAS Studio to do for you, rather than actually putting in the code yourself.
Yeah, SAS Studio, I mean, like I see, SAS Studio, they have given you the code already for you to that get that export, exported the data into, sorry, here, see, into SAS, zip file, the content, this one, see, that one, sorry, here, see, this one, exported data, you can convert into what? Into a SAS data, see, by giving this see, code. And if you want, you can put that into this transport, this one, this folder. Or from that one, you can put it into this folder. That's why they say, get it from transport folder and then put it into the data out folder, this data set. This is the name of the data. See, CDF, CD, see, BRF, S10. See? So that if you want, you can keep here too and work with that one. Or you can put it to data. See, another folder. See, that's what we are doing here. See, transport, export. See, in that one, the thing is that you cannot extract this data. There's a situation here. You cannot extract, okay, data from where you have saved on your computer. You have to get, because this is web-based SAS. Because of this one web-based SAS, you have to make sure that you're gonna get all the information, your data, and then put it in your server, their server. See, their server. You have to get into the server, and from the server, you're gonna recall. Okay. So same pretty much the same way you have saved onto the computer. From computer, you have to get in over here. See, files here. See here. See, now you can upload. See, upload to the server. From the server, you're gonna have that recall to this platform or studio. See? They have given like a certain number for that particular server. See, under that one. See, since we are using this one, since we have not, sometimes you might have like installed that SAS with you. That's the way you used to do that one, because I have that SAS. I cannot open. See, SAS Studio that 3.6. There's some kind of an issue with the browser, plus that they have that license gonna be expired pretty soon, like in 2-3 months. Because of that, I decided, okay, go ahead and go do that one. See, so you go ahead and see, click on this one and upload. See, when upload, the path has already created. So you have to choose the file where you have that one. So you can remember wherever that you have the file, go ahead and choose and upload. Then I had already uploaded that one. See, it's over here. I'm sorry, here, this one. See, it's still in XPT. See, so this has to be converted into SAS by, see, even this command. See, you go to that place, home. See, from the home, see, home. Under this one, again, that see, since they have given that one, it's been repeated twice. But anyhow, that's the path that I'm using all the way up to go to this one, and then gonna get export and put it into transport. This folder.
Are we all using this same? Have we all been given access to this server? The same one?
Yeah. You can have your own server, because when you're going to create, you have a different number. Should be a different number, not the
Okay,
same
that's
number.
what
I
I'm
think. Yeah, I think you can check it that one. Yeah. Anyhow, that you cannot work until that you're going to get the data that put it into the server, SAS server. Yeah. See, that's the best thing. Get that one and put it over here. See? And then if you want, as they mention over here, see, you can put it into data out folder again from there to there, because I'm going to get out from transport in and out to data out that data set. See? By the time their data set name is this one. This one. CDB BRF S10 SAS. See? Instead of that one, see, go to the library. See? The library. See? See? If you go to the library, you can see that one. See? Data out is not there. When you run that one, let's say we're gonna run. Okay. Let's see. This one I'm gonna run to. I see some error, but let me see. See, data out. See, it's in data out. See. And if you run this one, okay. So they have given this, see, you can see, you're gonna get the data in. What I did was that earlier that I got the data into the server. See, server files and folders. There's no way you can access anything that while you are working on that one to your computer. You have to get all the information and keep over there, data and everything in the server. See, you have work with the server, and then you serve even you are that this one, that SAS code, this file, I have saved to their server. See, that's why they have given everything free, because sometimes they might have that all the information they can easily access. I don't know. See, see, all the huge data, everything they can easily access. See? So this one even, see, chapter 1 SAS, I have saved that one. See, this is the data. See, SAS data. It has been now converted into SAS. See? It's the code related to that one. It's up to here. That's it. Where that is. I think that since it's that already over there, that's why. Okay. So already over there. See, my one already over here. See, this one and here, and plus it is in. It's from the transport. It has gone to data out. See, go to the libraries. Okay. CDBRF stem, the SAS file. And here servers. See. Get into the server. Right? These two, the way that they have given, see, this is that definitely that they have thinking that you can extract everything from your computer, but this time no. See, that's why they have given like this. But see, So once you have data, then we're going to play with the data later on. Okay. But we're going to come to that one later on. So mainly that make sure that you're going to get that data into, see this one, get into the server. From the server, you're going to convert that into a SAS, see, SAS data set. Okay. And then rather than working with this one, you now work with the data out folder, see, folder, the directory, see, this directory, all we call that on the libraries here. Library directory or the folder, that's the same thing, see. The rest come later, okay? And you can check the contents, see. See, there are observation, this many observation, 451,075, variable 397. See, everything, all the information here. See, there are description about the alphabetical list of variable and attributes. All the 397. See, not type, length, format, label. See, yes, 1, 2, 3. I don't see the whole thing. See, different that, see, let's say that, see, live with anyone with the different mental ill, we have your parents, see, blah, 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 so many things, see. So many information about their, that health condition will that be taken over here into account. So, 1, 4, okay. Like that, okay. So before we're going to come to that one, then later on that we're going to talk about that what we are trying to do over here. We are trying to make a contingency table. Why we're going to use the contingency table is the key part that we have to look into here a little bit. You know mainly that your variables, see, you know the variables. You have a variables or data. Data mainly categorized into two types. Which one called the qualitative, which is called the categorical. The other one is quantitative, see, and numerical. See? So this one again is going to be categorized into nominal, just the label, or that categorical data can be ordered. Like let's say that, for instance, like if you think about some example, height, street addresses, pin number, and temperature, temp, given in degrees Celsius, degrees Fahrenheit, or Kelvin, like that. See, and again on this side, you're gonna have like either discrete, see, discretize. There's nothing in between. Then you give the two numbers, 1 and 2. There's nothing in between. But continuous, see, continuous. Continuous means there are so many, infinitely many numbers in between two numbers. Again, this is gonna go down, ratio and interval. Same thing here, ratio, interval. See. So out of this given example, if you're going to categorize that, this one, we're going to stop over here. Let's say that therefore, based on that, whatever given that, let's say the numerical value, height, see, height is definitely come under this one, height. And pin number, temperature too, sorry, temperature, see, doesn't matter what unit they're going to use, see, degrees Celsius, degrees Fahrenheit, or Kelvin. And pin number is just a label, pin number here. Street addresses, addresses also label. Then pin number, out of pin number and addresses, which one is nominal, which one is ordinal? Nominal one is just the pin number, it's just a label. Addresses, they can order in ascending or descending order, like a letter grades in a class, A, B, C, D, E. Same way here, street addresses, see? Street addresses, see? Like that. When it's come to the height and temperature, out of these two examples, see, out of these two examples, height, we can say that it involves with the decimals, okay, for time being. Because of that, I'm going to call that one height, continuous. Discretize. Temperature, you can say with the just like just the number only, no decimals. Let's say 70, 80, 85, 81, 82, 83, like that. Temp, degrees Celsius, degrees Fahrenheit, and Kelvin, see, like that. Then height again, ratio interval. Ratio interval is completely determined by when you go to the height and looking into the zero and see whether it's going to be a placeholder or absolute zero. When you go to the height zero, that makes sense. It's not a placeholder. It's a makes sense because that person has not even been born. So because of that zero does make any sense, we're going to say that one is ratio. See, height. See, zero is real or absolute. 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 But when it comes to the temperature, let's say the temperature has been given in degrees Celsius for my convenience. Degrees Celsius, if you go to degrees Celsius, see, certain temperature, zero, you know the zero, degrees Celsius, zero. Would that be a real zero? Still a placeholder. Or do we have a temperature beyond that point? Yes, we have a temperature negative. It's going to go all the way up to negative this one, no? Negative 273.5. Because of that one, this zero, we're going to say placeholder. Since it's a placeholder, the temperature measured in degrees Celsius or degrees Fahrenheit would be what? Sorry, I wrote at the wrong place. Interval, because it's a placeholder, it's not a real. See? 10 degrees Celsius or degrees Fahrenheit. See? But when it's come to this one, this is what? Kelvin zero. That's absolute. In Kelvin, absolute. Absolute to real. If you're going to measure that one in Kelvin, the temperature is going to be ratio. See? Kelvin doesn't have degrees, okay? Like that. That's a rough idea how it's going to be, okay? So this is the classification, major classification in statistics. But in data science, what we're going to do, we're going to mainly any of these, see, call anything in that branch or anything in this branch separately called by qualitative and quantitative. Regardless of that qualitative being subcategorized nominal and ordinal, we don't take into account those ones, either nominal or ordinal, anything categorical one, we simply call the, you see, CAT. You can simply call this one CAT for abbreviation, categorical data. For the quantitative data, numerical, discrete, continuous, ratio, interval, or it doesn't matter. You're going to call that one quantitative data. I'm going to call that one quant data. See, quant. So in data science, there are no heavy sub categorization for the this one. This everything being simply called quantitative data. This everything will be simply called a categorical or string or labels here, quantitative or numerical or like that. Can I convert that this height into categorical? Yes, you have seen those kind of a thing in your like a previous classes in analytical analytics 600, 605. Can you remember height rather than going for the quantitative numbers? You don't like to work with that one. It's too heavy to work with the numbers. Rather than that one, you can group it. You can say short, medium, tall, like 3 groups. Can we convert into 3 groups and make it like a categorical? Yes. And then kind of can work with the categorical data like that. Yes, we can do that one. So this is the categorical data analytics we're doing in this class. Quantitative analytics we have already done in previous class. When? That's another question. When we're gonna do like that? When we have it, mainly you're gonna see one variable has been explained by none. Can you remember? You can remember that in the analytics 600, one variable, let's say that thumb length being explained by nothing, not another variable being utilized on your x-axis. Y-axis, we're going to keep the thumb length. It's called the empty model. Later on, you systematically add for the x-axis some kind of a qualitative variable, categorical variable called gender or height, categorical height. And then say with the gender, how the thumb length is going to vary. And later on, what we did, systematically later on, what you did was you added the quantitative variable for the x-axis to explain the thumb length, which is like a, let's say quantitative variable is height, numerical height, how it's going to affect the thumb length like that. That discussion you built up already. You can remember those three models: empty model, group model, and regression model. See? So that this is what I'm trying to say. This in the beginning, see, you have y. I'm going to call this one response variable. See, response variable. See, response variable. Here, let's say as example, thumb length, or simply I can say thumb. See, and there's no x variable, no x variables.
Would the response variable also be considered the dependent variable?
Exactly. There you go. Perfect. Dependent variable. That's right. Dependent variable. Dependent var. There are no x variable. I'm going to call that a no independent variable. Independent vars. Okay. Vars I utilize here to say the variables. Sometimes you use the var for the variance as well. But see, there's nothing being utilized. You utilize it's what? The average. Y bar. See? Average thumb. I'm going to simply call thumb. You're going to utilize the average thumb. See, from that one you wrote the model. Can you remember? Data equals the model plus other stuff. You can remember this one. Data means y. Model means what? Y bar plus this is error. See, y is what? Thumb. Y bar is what? Average thumb. Plus error. See, that's that regression model. This is called the what? This one called the empty or null model. You can remember null model. See? On the other hand, that see, for the I'm gonna give this one. Give me 1 second. I'm gonna give another name for this one for you guys to sometime in research. It's better off to use that word to make it like a more elegant.
You could also call it what, the null hypothesis?
No, null hypothesis come on later on. That because a null model you're gonna utilize, and then if you wanna estimate something, that's come under the inferences. That's the same thing that we have here too. So that's why you have to get a clear-cut idea. The model is separately we have here. This is the model. So I'm gonna write one step beyond this one for you to see clearly. With this one same thing, I'm gonna write with this one like this. Y equals, look at how I'm writing, B naught plus error, E. B naught is same thing as Y bar. Or sometimes practitioners, they like to write that this say Y hat plus C. Because that's the same thing. Y bar, B naught, Y hat. Y hat is the estimated Y. Let's say that you have a Y here. See? You have Y data outside. See? See? Like this. See? Outside. Then you're going to see that your Y is how far from Y bar. That difference is called the error. See? You know that one. That's the error. That's the error. That is denoted by E. See? So then you can test this B naught. You can remember that discussion we built up in those classes. This B naught, do we really have this model or not? Then you can test the B naught. But here we don't do that one because we're going to test this one against another advanced model. So we're going to keep this model as our like a basis model. This is the basis model. It's the basis model. See, that's the same thing. Error means C. You can see if there's no gap like this, when you draw the line, if all these data points are, if they were going to fall on this line, there's no variations. Since there's a variation, that variation is called the error. Error has to be tackled. That's what we are doing in data science and data analytics. How to minimize the error. This error has to be minimized. This is why we call this kind of every event called the probabilistic or random event. Every event in this universe are random except for sunrise, sunset, and death. But death is the only fixed one. Other than that sunrise, sunset, the event that we considered, they were randomized because that sun is decaying all the time. Other than that, there are no deterministic. See, if it is on this line, it's called deterministic events. There are no deterministic events. Everything randomized. Whatever you learn in math classes, engineering, everything, they were based on deterministics. But later on, when you go to any advanced classes, PhD, research level, that level, there's no deterministic model doesn't work very well. That's why probabilistic model heavily utilized in order to come up with the solution at the end of the day because of this guy. Even in the like anything, any engineering, any model, those are deterministic. They work because if you measure that once 2 times, same measurement, the current through a certain circuit or whatever, that you're not going to get the same answer. It differs because that difference is called variation. Variation is characterized by the error. So that's why probabilistic models are very, very important. So these are probabilistic models. These are random models. These are, if you incorporate the time factor inside this one, they're going to say, with time, this is going to change. Like that, you're going to, that the thumb length, you're going to measure the thumb length over time. Like a newly born babies, thumb length can be measured over time. Like in the stock market, you can see the fluctuation. They're so close to each other, then we're going to use a different kind of a setting called the time series in that situation. But let's say that here, that even time factor you incorporate, the statistical model become later on stochastic model. That's heavy. And stochastic model, how come you're going to data science can be applied to the stochastic model? It's the key part. Those kind of things you can see down the road. And on the other hand, the related to this one, if you go to the second model, you can remember for this guy, see, we can say 2 group model. I'm going to use the 2 group here. Okay, 2 group model. See, so 2 group model, I'm going to introduce, see, y. And on the other hand, this variable is quantitative, see, quantitative, cont. Okay, variable. Now again, thumb length. I have thumb length, response variable, thumb length. Okay, thumb length cont. I'm going to explain by and introducing a categorical variable called gender. See, gender, categorical variable. Okay, you have a female here, male here. Then you have a, see, data like this. See? Then you have a, they are mean. See, they are mean. That called the, you can say y bar of female. Then you can say the y bar of male. See? Then you can say this one and this one. You can say this is same as B naught. This gap is B1. And on the other hand, this one, this y, if you go back to the previous one, y, this one called the intercept. Intercept plus error. See? That B naught is intercept. Y hat, B naught, average thumb, y bar. Everything represent the same thing. See? Intercept, y hat, B naught, average thumb, y bar. They all represent the same thing in this model. In a similar fashion, here you can see, you can write the model. You can say that some see, you'll see females y or males y. See how they differ from this, and look at, they differ from y bar. See? They differ from this guy. At the same time, you have that mean too. See, grand mean y bar. That's called grand mean. Regardless of the gender, you can calculate their mean too. It's already there. So this kind of a thing, again, you can say your model would be data equals model plus error. Error means other stuff. Okay, I'm gonna call error because you know then you are familiar with. So you can write this on y b0 plus b1 x plus error. See, x has two parts. Then x equals 0, x equals 1, x equals 0 female, x equals 1 males. See? It's the same thing. See? You can write like that. See, these are called what? Indicator variable, indicator or dummy variable. You're going to utilize. Since you have two groups of the categorical data, those are the categorical data that we are trying to analyze now pretty soon. So we are heading towards there. See, so see, that's the model. B0 plus B1. Here B1, B0, we can say this one, B0 is what? Intercept. B1 is the slope. Slope is nothing but the difference between the two means. See? Difference between the two, the thumb lengths, see, average thumb lengths, difference between these two groups. This one is whatever that you consider as the average of the females, thumb lengths, B0. See? See? Like that. You have learned all this stuff. And later on, what we did was that we replaced that categorical, this one, the third model called the regression model. Regression model, see? Third model, regression model. Regression model, both are quantitative. Okay. Then you're going to use the regression model. Okay. So regression model, okay. Here, y, again thumb length, okay, thumb is quantitative. See? Now this time I'm going to put x equal height, another quantitative variable, see, another quant. So then you have a data, see, scattered all over the places. That's called the scatter plot. Scatter plot. Okay, then you're gonna join that one with describe that one with the straight line in the primary stage. Later on, you can go to the curves and all kind of stuff. You did that one, and or combine 2 points at a time called the spline regression. There are almost like 10 types of regressions. See, then you can write this equation. See, this equation. I'm gonna write this equation. I'm gonna write this one. Okay, abbreviation for equation. Equation of the line. You can write y hat equals b0 plus b1x. Okay? Like that. And the model you can write data equals model plus error. This is the model. So you can say y equals b0 plus b1x plus error. Okay? You have done this stuff in large scale. See? Now what we're gonna do, we're gonna summarize this discussion in this way. If you summarize, you can see you have mainly two types of variables. See? You have here response variable, which is y. You have here you have its counterpart called explanatory variable or x variable, which is x counterpart. So if you have this one cont and categorical, this one also cont, or either cont or categorical. If both are cont and cont x and y, we use what? Regression. If the categorical, response variable categorical, explanatory variable quantitative, then response is like a yes, no. Then we're going to use the logistic regression. Discriminant analysis. Those kind of things.
Would you also use a decision tree or a random forest?
No, I'm just like simply gave where we are heading towards, why we're going to go to the chi-squared. Okay, that's what we are trying to do. Later on, we're going to see the categorical to quantitative. See, you have the categorical variable for x. Quantitative, we still can use the group regression. Group regression has the same thing that you saw earlier, like a male female categorical variable for x, and the quantitative variable thumb length. You saw that one. So in that case, that you can remember that we're going to call that one either that or analysis of variance. Analysis of variance. Or that acronym, this one like ANOVA. See? Analysis of variance. ANOVA. Now the categorical to categorical is the key part now. The both response variable as well as explanatory variable categorical. We use what? Pearson's, see? Pearson's chi-square test. That's the one we are trying to learn in this class. Or Fisher's exact test. See? That's how that we came to this discussion. See? So these two mainly we covered in previous classes, mainly this one. This one we covered 600. Empty model 600. Then group model in this model in 605, 620 mainly that we covered these two, and this is where we are right now. This 620. See mainly that we covered this one in 605 and 600. Sorry, 600 and 605. See? This is this one and see 620. This one too, and 620. We covered that one. So this is where we are, and now 625. We do the categorical data analysis. Call that both are categorical. That's why we are using this Pearson chi-square test. So when it comes to that one, you're gonna mainly use what? For this one, you use a contingency table. Contingency table. Contingency table is like a table like with the rows and columns that will have a, like your two variables on that one side and the other variable on the other side. See? Or confusion matrix. See? Or confusion matrix. The confusion matrix. So that one that we mainly built up that this contingent table, this one, put in this one, and discuss that various things. Like for instance, that if I start with something like this, look at this one. This is a contingency table. See, look at in this example. You're going to hypothesize. I think you are familiarized with this one too. Somebody asked about how the hypothesis testing comes into the picture. This is where this comes into the picture. And this is where that contingency table comes into the picture. This is where that the tree diagram, see, vision tree, see, comes into the picture. All comes along with the same setup. So how about this one? What do you call this one? H naught. See, we normally call this one H naught. H naught. H naught. See, H naught. See? So in statistics, statistical inference, okay, is a key part. That's the backbone of statistics. Statistical inference. There are two parts. One is estimation. Estimation of unknown parameters, okay, such as population. I'm going to write population, this abbreviation, population, mean. See, mean. This is very famous, mu. See, that letter mu, you know that you are familiar with this one. Median, mode. See, I'm not going to use the notation for that one. Variance. Variance, you can remember that. It's denoted by sigma square. And standard deviation, I'm going to say ST for saying which is sigma, etc. See, estimation of that one. Not only that, and then what? Slope. Slope. See, beta 1. Intercept. Population 1 we call beta. Beta naught. See, beta naught. You can remember you did the what? Proper proportional reduction of error, pre. R squared, you can remember those things. F ratio, etc. See, not only that, under that one, under estimation. Okay, I'm gonna little bit go up to this one. This one, under this one, estimation of unknown parameters such as this one. Then under that one, O, you have these two, okay, like this, okay. Statistical testing, testing of hypothesis, testing of hypothesis, testing of hypothesis. Those are the major two branches. And under this one, again, you have what? Point estimation and interval estimation. Interval estimation. These are the key part in that whole discussion. Because when you have when you don't know this stuff, you can get the point estimate for this guy. What would be the point estimate for mu? Y bar. What's the point estimate for median? Sample mean. This is a population median. I can say point estimation, see, such as see, sample mean. Sample mean. See, because we're going to utilize a sample, Y bar, and sample median. See, sample median. Sample mode. See, sample variance. I'm going to call that on 1, which is a squared, the comma, sample standard deviation, which is S, like that. See? Interval estimation, you can remember how we wrote the interval estimation for that guy. When we give like a one variable, one value, we are not happy with one value. We really need to get the so many sample again and again and again and build up like a whole bunch of estimates. It's a collection of estimates. You say, for instance, if you want to that, I'm going to say confidence interval CI for mu. I'm going to write like this. You can simply say Y bar plus or minus margin of error. You can remember these stuff you have done already. See, margin of error. See, on the other hand, on this one, hypothesis testing, if you want to test something, you're going to say H naught. See, H naught means null hypothesis. H sub naught or H sub 0, or simply we call H naught. Null hypothesis, you're going to say mu equals 0 or something. See, versus its counterpart HA, alternative hypothesis, you're going to say not equal 0. See? It's a testing. See, that's how they were connected to each other. Here you're going to estimate. Here you're going to find a whole bunch of connections, the range of estimates. Here you're going to check and see whether that whatever the claim, this is for the claim. This claim is true or not. See, that's called hypothesis testing. Hypothesis testing is a counterpart of interval estimation. These two are, they are twins. They are twins. This guy is a counterpart of this guy. They are twins. So in statistics, all the time you have a pair, sample, population, statistics, parameters. Estimation of hypothesis, interval estimation, point estimation, like that. All coming, but pretty much all the time, everything's coming like a pairs. See? If you want to run this one, you really, really need, if you take this out, because this one guy, you have discussed this one in large scale in NR 600, 605, NR 620, 615, I think, those classes. See, this one, even you have talked about in large scale. See, testing of hypothesis. I'm going to pull that out. Testing of hypothesis. See, H naught, you can say H sub naught or H sub 0 or simply you can say H naught. Use H naught. That means null hypothesis. Okay. H naught, see, mu. Population 1 is 0. See, versus its counterpart. See, this one you can say H sub A, or simply you can say simply HA. Alternative. You have to give the alternative all the time. You cannot just simply hypothesize one thing. If this like this claim, this called the claim. Here we're going to say mu not equal to 0. If that thing, because of the not equal sign, because of this guy, we have a two-sided test. You have a two-sided test. If you have a greater than or equal, sometimes you can claim and say that average speeding ticket would be $150, more than $150. So the police department, they're going to claim and say it's going to be on average that the speeding ticket would be more than 150. Then with the statistician or the city or that county or the district or the state, they will really want to make sure that that's true or false. If you want to check that one, you're going to that built up this kind of ascertains, ascertains and all the conjectures, propositions. These are called the propositions. See, hypothesis. See, hypothesis, propositions. You can say, or conjectures. See, true or false. If you put the greater than sign here, greater than or equals, always go here, then less than. If it is less than, you have by looking at this one, your claim would be greater than. You cannot put over here. You have to put here claim greater than. Sorry, greater than here, and because of greater than here, say more than $150. If that's the case, that you have to put here less than or equal. So simply put equal sign here. So then greater than means you have a right skewed. So sorry, right tail test. If it is less than, you have a left tail test like that. It depends on the situation. See, this is how they're gonna do. In order to do this one, you really need, see, in order to run the test, you really need something called test statistic. In our discussion, our major test statistics would be pi squared, see, x squared. That's the one we are trying to build up over here. See, we really need this one. And this will be then compared, contrasted based on the decision rules. How to make a decision rule based on this one. You can use the confidence interval procedure. You can use the p-value procedure. You can use the confidence interval procedure, p-value procedure, and then comparing that one with the critical value. See, I'm going to call this one x squared for time being. We're going to build up pretty soon that how it looks like. See, this in statistical inference like that. See, you can see what we're trying to do over here. Or this can be compared and contrasted with against a certain number. The same mu equals to 50 average, 150 as I said earlier, versus mu average that speeding ticket would be not 150. The police claims that one. We want to say whether this is true or false. We're gonna just run a test. See, in order to run a test, it's like a same thing like in a courthouse. You really need a evidence. Evidence means here data. We built up the data. You collect data. You have a data set in your hand, massive, huge data nowadays because of after invention of this internet. You are dealing with the massive data. Earlier we didn't have. That's why everything was done by hand. But nowadays we don't do like that. We're gonna let the program or the robot or the machine to do the calculation for us. That's the beauty of data science. You don't involve with anything, but we have to get a clear idea what's going behind that one. Rough idea, not in heavy detail or theory. We don't do theory here. We're just showing you the process. I'm just simply showing you the process only. See, those are not theory. These are processes. See. So this is the part, as I said earlier, that we are interested in categorical versus categorical. How do you tackle Pearson chi-square test? As I said over here, you really need a test. Test is done by for this one. So if you get back to this one, I'm gonna say that in the beginning, see, the patient is that healthy. Patient is healthy versus the patient is what? Deceased. See, you can build up like that. The patient is, see, you can hypothesize H naught. You can hypothesize something. Or it's other way around. If you want, you can say patient is deceased versus its counterpart. See, H naught. The patient is healthy versus its counterpart HA. The patient is deceased. See? Okay, in this scenario, how this going to be connected to like a categorical data analytics, like the one we are planning to do? Look at in the very beginning, he thought that based on that first test, or he has done some test based on that, based on changes in your the physical changes or the any changes, he feel like that sick. If it is sick, I'm gonna say it's sick means like a D, deceased. H naught is false. See, H naught false because sick means H naught is false. I'm gonna write in terms of H naught as well. Healthy. Healthy means either you put the D or D bar. D bar means it's complement, or you can put H. H naught is true. And this is the first test. See, condition. See, two categories. See, categorical. Condition is categorical. See, it has two options. And then we're going to go ahead and do another test, second test. Then results may be what? The positive or negative. Positive or negative. See? So that means if you diagnosed as sick, positive means diagnosed as sick means you reject H naught. H naught still reject you. Earlier you call that one a false. Now say I'm going to reject H naught. H naught is not true because that patient is deceased, positive. And this part I'm going to say accept H naught. And this kind of a say two options. This is a contingency table. This is where that we are trying to use the chi-square test. This is where we are trying to build up all the theory behind this one. See, all the processes, we're going to get a clear idea. See, let's say that for you to get a more, see, the same thing over here. Look at that here. See, gender and whether you have a diabetes or not, or whether you're doing exercises or not. See, like that. See, same kind of a discussion we built up. Okay. So here, see, I'm gonna say, okay, I'm gonna build up this one. I'm gonna say condition. Your condition in reality. See, you have a two options. Whether you are deceased, okay, sick, okay, deceased, or deceased, maybe B. That means I'm going to reject H naught. I'm going to write that one in terms of H naught as well. See, reject H naught. The other one, you are healthy. See, healthy means D bar. You can say D bar or H, healthy, to denote that one. H. That means what? I'm sorry, not reject H naught. H naught is H. I'm sorry. H naught disease. I'm gonna say H naught is false. I'm sorry. H naught is false. H naught is false. This one I'm gonna say H naught is true. It's true. And then your second test. See? This one. Now you're gonna go ahead and get the test results. See? Test results. Another categories. You get the positive results. You get the negative results. If you get the positive results, you're gonna say what? Reject H naught. Now you can say reject H naught. You are disease. See, this one, accept H naught. Accept H naught, healthy. Look at this one. Okay. Without taking into account the numbers, if you want, you can put some numbers here. Okay, we can come to number. Before that one, look at deceased person. See, deceased person has been identified as like a sick person. See, deceased person correctly diagnosed. Deceased person correctly diagnosed as a what? The disease, deceased, you see, or sick person has been correctly diagnosed as deceased correctly. So H0 is false. Reject H0 when H0 is false. Reject H0 when H0 is false. Another way to look at it. That means it's a right decision, correct decision. See, that's decision right. And in this case, H0 is true. That means healthy. Healthy person has been correctly identified as healthy. See, except H0 means healthy. That's the correct decision. See, decision right. But the other two cells, these are called the cells. This is called the 2 by 2, 2 by 2. This means number of rows. Number of rows. If you want, you can put capital R for this one. Number of columns. Columns, you can put capital C. Okay, which is 2. Okay, here, this one 2. 2 by 2. 2 by 2 contingency table. See. 2 by 2 contingency table. Each one is called the cell. These are called cells. See, cell. What cell is that? See, plus and D, if you want to call it plus and D. You read that rows first. See. Then what? This one. What's the problem over here? See, these are correct decision. This is wrong. This is wrong. Look at here. H0 is true. Healthy person has been identified as a diseased person. Incorrectly, healthy person has been identified as a diseased person. Incorrectly, diseased person has been identified as a healthy person. See, both decisions are wrong. On the other hand, since this one, the disease H0 is false, and that that positive answer is true. You can look at this one is, see, true. This one true. Disease means, see, positive. See, look at that. You can say true positive. See? Positive, but it's true. I'm going to put this on TP. True positive. Then this one what? Positive, but it's not right. See, positive results you gave for the wrong person. False positive. Negative. Negative has been given correctly for the negative person. That's a true negative. This one false negative. FN. True positive, false positive, true negative, false negative, false positive, false negative. Those decisions are correct. That means you reject H0 when H0 is true. You reject H0. You have been identified as disease based on this given scenario. It's a in the given problem. When you are healthy, person being identified as a diseased person. That rate I can write like this way. Look at what I'm gonna do. I'm gonna write this one probability. P for the probability. See, probability. Probability. See. Probability. See, I'm gonna say this one like this way. Okay, probability. See, sick person. See, positive results given that person is healthy. You get the positive results given that you have healthy person. Healthy person has been incorrectly identified as deceased. The probability of incorrectly identifying healthy person as a deceased person. See? That's another way to look at it. The probability. See? I'm going to say probability. See? Probability of incorrectly identifying a healthy person, healthy patient as a deceased. That one I'm gonna write probability. See, plus given healthy is called given or this called condition, conditioned. See, when, another way to look at it, see, like that. Oh, I'm gonna write this a probability. Reject H naught when H naught is true. See, reject H naught when H naught is true. H naught is true. You reject H naught. That's a conditional probability. Another name for this one, conditional probability of. See, we can say conditional probability of. Incorrectly identify a healthy person, patient as a deceased. See, probability of rejecting H naught when H naught is true is nothing but committing type 1 error. Committing type 1 error. That's called the type 1 error. See, type 1 error. Probability of committing type 1 error. Type 1 error means reject H naught when H naught is true. See, another way, it is the probability of making false positive. See, false positive. False positive. See, probability of false positive. Therefore, I'm going to call this one false positive rate. Rate means probability. See, rate. FPR. Or simply, I'm going to denote this by alpha. Alpha is very important. It's nothing but level of significance. Significance level. This one has another name. It's called the size of the test. Size of the test. Size of the test. It has another name, 1 minus specificity. 1 minus specificity. So all these names has been given for the same guy. So sometimes we call the type 1 error rate. Type 1 error rate, if you want, you can call the type 1 error rate. Okay, that's the same way. False positive rate, FPR, alpha. See, level of significance, size of the test, 1 minus specificity. Pretty much all these, probability of rejecting H naught when H is not true. All these, see, so it's like I say, same thing. See, same thing. You can utilize this one even in the court also. See, innocent, guilty, sorry, innocent, culprit, found guilty, not found guilty. Like that same thing. Sometimes they make the mistakes, 2 mistakes. These 2 mistakes can be remedied easily if you go back and check. But in the legal system, they don't do. But even for that biomedical research, even they're supposed to do. That's why we are using the Bayesian analysis. Okay, see, level of significance. Okay, this one, 1 minus specificity. So if that's the case, you know specificity is nothing but what? This guy. See, these two go together. Not this way, this way. See, specificity means correctly identified. That means true negative rate. Another way. See, another way, true negative rate. So on the other hand, what is the mistake over here? See, you accept H naught when H naught is false. It's false. Why are you going to accept something when it's false? He's diseased. You're going to say he's healthy. See, healthy person incorrectly. That one. That's called the type 2 error. In a similar fashion, those are conditional. Okay, given. Okay, we're going to condition first. What something happened first? He's been healthy, but now from the second test, he's been identified as the positive. In a similar fashion, we can say conditional. Conditional. Okay. Conditional probability. I'm going to say probability of, see, conditional probability of, see, incorrectly identifying the deceased patient as healthy. Healthy. Probability, see, negative is deceased. See, that means probability. See, this is probability. You're gonna see H naught is false. This is, you accept H naught. Accept H naught. Accept H naught given that, see, this one conditional. So that's nothing but, see, committing type 2 error, probability of committing type 2 error. Also, you can say type 2 error rate. Or you can say probability of what? Probability of false negative. See, false negative. Or you can say false negative. Or you can say false negative rate. False negative rate. This is denoted by what? Data. See, data. See, data. It's nothing but 1 minus power of the test. Power of the test. It's nothing but 1 minus specificity, sensitivity, 1 minus sensitivity. Sensitivity. 1 minus sensitivity. It's the same thing. See, so you have that. But in a test, when you run a test, power and the size to be balanced, size of the test and power of the test should be correct, should be balanced. How could it's like that some kind of a seesaw on a fulcrum? You have to balance. Higher the sensitivity, lower the size, higher the and vice versa. Lower the higher the sensitivity, higher the size, higher the sensitivity, lower the size. So you have to have a balance. Make sure that they balance. How could you gonna balance? Alpha, you're gonna decide alpha. Alpha being given. Normally alpha is 0.05, 5%. No, and you remember pretty much in most of the test, we're gonna keep this one. See, 5%, 0.05. See, that error can occur with only out of 100 times. If you do experiment 5 times, you make an error. That's okay. It's acceptable. You're gonna leave that space for to make the error because there are no perfect system. Sometimes 10%, sometimes 2%. See, like that. See. In another way, if I add to this one, another thing to this one, 1 minus, this is nothing but, see, level of confidence level. Confidence level. That's another way to look at it. As I say, that testing is completely connected to that confidence level. See, confidence level. 1 minus confidence level, 1 minus specificity. If that's the case, see, throw this one again, this contingency table in this categorical data analytics. So here you have a deceased, P bar, positive, negative. This one, see, true positive, false positive, false negative, true negative. See, you can remember that one. And on the other hand, this branch here, you got the false positive rate is what? False positive rate is size, see, for 1 minus specificity. Then this should be the specificity branch. That's the specificity. That means true negative rate. See, false positive rate, true negative rate, false specificity. See, then false negative rate, I call that one 1 minus power or 1 minus sensitivity. If that's the case, true positive rate is what? Power and sensitivity. Sensitivity. Okay. sensitivity. See? 1 minus specificity. Or we can call this one alpha. See? This is 1 minus alpha if that's the case. This one you can say beta. If that's the case, you can say this one 1 minus beta. See? Then you can draw a graph between what and what to find the check and balance between what? Sensitivity, which is power, which is 1 minus beta versus specificity. Specificity. See? I'm sorry, 1 minus specificity. 1 minus specificity, which is size. See, which is alpha. See? If you draw between this one, those are probabilities, cannot exceed more than 1. See? 1, then you're going to have this one. See? Then you have a, see, healthy person cannot be distinguished from the diseased people. This line called the chance line. There's no, it's not distinguishable if anything gonna fall on that one. But for a given any threshold value based on any biomarker, let's say that take a blood sample and send to like a laboratory, and based on that one you have decided through a certain threshold value, see, certain threshold value. Okay, that your data will be like that. See, this one called the receiver characteristic. See, so I'm sorry, characteristic. That one we call the rock curve. That means receiving, say, receiver operating. I'm sorry, operating characteristic. So that's the rock curve. If you go ahead and look at that, this one, there's a line. See, there at a certain point, your line is parallel to this one, chance line. That point is, see, that's the point you have optimal cut point, optimal threshold, cut point, or threshold value. See, you can utilize that one in your biomarker to distinguish healthy from the disease. And this distance between this one is a minimum. That distance you're going to call the Uden index. I'm not going to get in there, but I'm trying to say that this everything then popped up that when we had this discussion, this is a contingency table. In this categorical data analytics, you can very all the time see this kind of stuff, a rock curve. See, it's called the rock curve. Rock curve is heavily utilized. An area under the curve, see, that area under the curve called the AUC, see, area under the curve, see, has been utilized to check whether diseased people being, see, AUC, area under the rock curve, see, curve had been utilized in order to check whether that disease, how to distinguish healthy from the disease. Because that when you come to the like when somebody is deceased, based on some kind of a biomarker, those are called the biomarker, means some kind of a specimen, like I get the blood sample, urine or something like that. In that, by checking that one, how could the medical doctor knows that whether this person is healthy or diseased? It has been determined by the data analyst and the statistician by carrying out that data analysis for a long period of time, and then carry that collecting data, analyzing data, and come to an optimal cut point and say, hey, this is the best cut point for you to decide this person is healthy or diseased. Okay, like that. That's why they are using, or its counterpart area under the curve, or Uden index can be utilized in order to that come up with this anything. Like earlier I show you that my paper that I was doing, that one is about the inferences of a Uden index. It's a heavy one. I'm not using one biomarker, I'm using several biomarkers at the same time. And then do the very heavy process, the framework. We are working on generalized variable. That's a heavy framework. Because normally this any data you see, or this all kind of a computation calculations are you are doing on a classical framework. There are so many frameworks in statistics: classical, Bayesian, non-parametric, semi-parametric, fiducial, generalized variable, like that. But when you have become an elite data analyst, you have to know this all the frameworks thoroughly. Sometimes some problems you cannot tackle in the classical framework. You have to jump into the Bayesian. From the Bayesian one to you have to jump into non-parametric, non-parametric to fiducial, fiducial to generalized, like that. If you have the more knowledge, you have the far better would be at the end of the day. That's what I'm trying to say. Okay. But anyhow, this is related to this discussion that we are trying to build up over here into the contingency table. See, this contingency table has been utilized. Now they want to see, is there any relationship between these two? They really need some kind of a test. That's the test they are calling the Pearson chi-square test. As I said here, when you have some kind of thing, see, healthy person, see, versus the patient is diseased. See, this one, see, by these results, this is there any correlation between these two? Are these two independent or not? If you want to build up that kind of a discussion, you really need to know that the test variable. What is the test variable we can think of? Look at this here. We go to here that let's get something to add to this one. Look at, these are the readings that you have to do. See, sometimes it's not okay. See, for this week, see, basic concept, practical aspect, where probability, type 1, type 2 error, you saw the categoricals and the data. See, first classification and SAS categorical data analysis from that one, chapter 1, 1.1, 1.2. See, Duffy Dino lectures on categorical data analysis. You have to read the chapters 1 through 5. And Agresti, chapter 2, Stocks 1, 2.6. Agresti, no, this book, no, this thing. An introduction to data analytics analysis. Agresti. This one, then this one, the other one. Categorical data analysis in SAS. This book that I think these are available, no, on that. Are they available here? No, not here. Sorry. Can you access those books? I don't know. Sorry. Why I cannot see? There's so many I open. I can't see very clearly. This one, the idea. This one, I'm going to get out of this one, get out of this one. Okay. This one. Now about that, I'm going to go to that website. Okay, this one. Okay, let's see. Here and so see week 1. Okay, sorry, student resources, see, post resources, Artura resources. What kind of a resource we have? What's our definition? This one. National resource, students access responsibility. Okay, so for week 1 readings. See, Duffy. One you can get that one. SAS categorical data analysis using logistic regression. That book. You can get that done. These 3, no, only these 3. You don't have this one, no. Stocks, categorical data analysis using SAS. This one using SAS. See, you can get the supplementary books. See, these two. Those are the two books that I showed earlier. See. And the lecture categories are Duffy and Dino. I think that's this one. See, that's this one. See. See, we were talking about it. The categorical data the same way that we were talking about, that why categorical data being utilized, because you have, sorry, contingency table we are using, we have the categorical data. See, see? Association, that book, see, and see, 2 by 2 contingency table. See? See? Look at the something like that one too. That let's get back to this one real quick and then come back. Okay. So related to this one, see, if you put the some numbers for this one, what this number means here, if you have a number here, what that means, let's say that before we gonna, that's the same discussion we have built up in over here, similar kind of a discussion. So let's say that now that here, see, here they have given numbers now. What this number represent? That's why we want to know what is this number represent, and then can I build up my type 1 error, type 2 error rate, or they are alpha, specificity, sensitivity. Can I calculate those things? Let's see what we can do, and then they, when I get a rough idea on how what's going on, when you run the program, they will give you that whatever you need. Sometimes they're not going to give everything. Sometimes you have to do some few things by hand. Okay. But anyhow, that let's say that I have numbers. I'm going to put these numbers for my convenience. Okay. I'm going to say I have a 20 here, this table. Okay. Here, plus, minus, this is healthy. I have a 20 here. I have 180 here. I have a 10 here, 180, 20 here. See? So this one, I'm going to say row marginal, row total, see, row totals, row total. Okay, I'm sorry, row total, right? Row marginal total. Marginal total. Here, this side, we have what? Column total. Totals actually, see, total. See, other way, marginal total. So this one you can get 30. This one you can get 2000. This one you have grand total. You can add column wise and row wise. This one 200. This one 1830. See, this one 2030. See, then you come either way that they will add to that. What this number means, this number is, this number, this number represent, what this number, that, sorry. This number represent what? With a conditional law, marginal law, there are 3 types of probabilities. Which one they're gonna represent over here? See, marginal, there are 3 types of probability. I mentioned that earlier I was talking about conditional. These are like a marginals. See, marginals, marginals, marginals. See, marginal. The probability of deceased ones. What is the probability of deceased one? 30 over 20, 30. 30 people were deceased. How many people healthy? 2000 people healthy. How many people that identify as positive, that how many people have positive results? 200 people. How many people have negative results? 1830. It's a grand mean, grand total, sorry, grand total. But these numbers represent their intersection. They were healthy, sorry, they were deceased, but there are 20 people who are deceased being identified as deceased. 20 people who had been identified, this is how 20 deceased people, deceased patient been identified as deceased. Healthy, unaided, healthy patients being identified as deceased. 1,820 healthy people being identified as healthy. 10 deceased patient being identified as healthy. See, non-deceased, non-deceased, deceased, non-deceased, deceased, non-deceased. This is healthy. This is healthy. Or another way, reject H naught, accept H naught. I'm sorry, H naught is false, H naught is true. H naught, reject H naught, accept H naught. Another way to look at it. So inside you have the joint one, D and this one, joint. See, this joint. It's a joint. But if you really want that conditional one, that here the conditional one, what are you gonna do? You have to get this one and divided by, see, if I really need this one. I really need alpha. I really need true. I'm sorry. I really need not the alpha. Sorry, specificity. I'm gonna say this one. I'm gonna say I need sensitivity. I need sensitivity. Sensitivity. Sensitivity is probability that deceased people being identified, that it's conditional. I need that one, sensitivity. But conditional one is a conditional probability. Conditional prob. It's given by joint plus ND. It's called joint. See? Divided by probability of disease. It's called marginal. See? It's a connection between three types of probability. Joint probability divided by marginal probability will give you what? The conditional probability.
I'm
Plus,
sorry, Professor.
go ahead. Yeah, go ahead. You go ahead. Yeah, you go ahead.
I'm sorry. I don't mean to interrupt you. Are you going to show us how to load that XPT file? I kind of want to play around with it.
Oh, I show you. No, earlier I showed you earlier. Can you remember? Okay,
yeah, I did, but it's actually I can't get it to load. Did anyone else actually get the data?
You cannot get it to load. No, can you remember? Are you using that? Did you get a chance to?
I loaded into the server, so it's in the actual server.
Okay,
and then now I'm using the code that's in the slides that we have, and it's not working. I'm still getting error messages in the log.
Let me see what's going on. So did you do these two steps? These steps?
Yes, I have those 2 steps.
2 steps. Okay. Then this one. Did you get this one?
Well, so that's the thing. It's erroring out. So I'm getting errors in my log messages. Let me see what it says. Actual error messages.
Where's the error coming from? Is that error message coming from that one? Let me see. I'm gonna run one more time. Okay. Okay, that's good. That means we get this one here. No, see, I got that.
It looks like your code does have some errors though, so.
Okay. Okay, then let's run this one. Let's see what's the one. Error, 4 errors. No, okay, what that error mean? Where is the error? Invalid character were present in the data. An error occurred while processing text data. Expecting a name. Option,
yeah, that's the one I'm getting.
Option will be ignored. What is that one? Okay, let's because we are trying to get this one into this one data home. I'm gonna go here I'm creating another library. See, it's a library. Okay, let's say that I'm gonna. This one should have this one. Okay, I have a home. This one, my shared files. Bring this one. Let's copy this one. I'm gonna copy. Run and see what's gonna happen. Expecting a name. What that means? Okay, I'm gonna run the contents. You see? Contents are already
Okay, so
here.
okay, so even though you get an error message, if I run
Yeah, I
contents,
think
the
that
data
I
should be
think okay. I want to have a look at it. Invalid characters were present. 2 errors. Okay, an error occurred while processing text data. No, my first time when I run, I didn't have that one. I mean, like not today, earlier, for the first time when I ran that one, I never had that one. See, so we can.
Yeah, mine says that it's not. It doesn't exist. So that means that it isn't.
It doesn't exist. Oh, your one doesn't exist.
Yeah.
Oh,
Yeah.
you don't have a
That's
that.
what-
You don't even get this. I mean, like you don't even get the result.
Yeah, yeah. No, I get no output.
Oh. Let me see. Export this one. Right. It's been got it over here. Then you're gonna convert this one into a data out and put it over here. So we're gonna do like this way. Date. I'm sorry. CDB 10 and data. This is here that all this when it's come to the transport. Okay, I'm gonna see. Data out from this one. See, transport. See, it's already in the transport. I'm sorry. See, it's here. It's here already. You forget about this one. Okay, then this one. Let's say that okay. Forget about this one. This is you are simply that change in another library. Okay. See, it's already here. This line enough. Within this line, with this command, it's going to go to this particular library or folder. It's already there. You can work with that. But what I did was from that one, I try to get to this one. That's what they were telling in that one. Looks like there's an, but this line, there's no error. See? See? Is that the same thing? Really? I'm sorry, I had to highlight that one. Did I highlight that one? See, no errors. No errors. See? It's in this folder. You can give any name for that one, any name. You can, if you want, you can say data out for this one at this stage. We are this here the way that they have suggested on that that book because we followed the same way that on this one. They say to they say, I'm sorry, here. See, they're changing the library in another library. See, they're gonna have this one in this one. Within the transport, they're gonna say put it into this one, data out to folder, bring it to this one. That's what they were telling. If you want, you can work with the transport if you see that data out that one.
So can you go back to the
Okay, I'm gonna go to the
so
program. Yeah, I'm gonna go to program back again. I'm sorry. Where's the program? Yeah. See here. Here. Transport. From the transport, I got it back here too. See, I have data out too. That's the same thing. See, data's here. See.
Yeah. So okay, so but the output is supposed to be a table called CD BFRS10.
Yeah,
right?
that's the
Supposed to be a
name of
table.
the that's the name of the table. CD BRFS10.
Okay.
So let's say the contents. If I say here transport, say TRNS trans PRTC, trans PRTC. Go to that one and work with that one. Let's say. See. You get.
Are we supposed to be enrolled under like 625? Because I have 610 and 6. Let me see which ones are under mine. 'Cause I'm not actually enrolled for SAS under 625. I don't know if that matters. Or not. Like it's like an old enrollment.
Oh, no. This is a SAS that you're gonna get it from the SAS, that company, and then you're gonna just sign up for that one. No, can you remember? See, I sign up for that one. SAS, see, on demand for academics. You go to the SAS.com.
Mhm.
From that one, you're gonna sign up for the this one. Earlier, this called the SAS what is the university edition?
Yes, but that so for each time we've had to use this, we technically have to like enroll in an actual class. So are
Oh,
you saying
yeah.
we don't
You
have
have
to do
to.
that?
I mean, like it's gonna stay for a while and then later on go away. See, that's why that I click on this one and see you have to come back sometimes. See, sign in. That's the major disadvantage of this one. That's the one being provided to us. See, make sure that you're gonna save that one. That's why I told you guys to save. See, make sure your work save. See, save. That's the only place you can save in the server only. See, it is in the server.
Okay. Yeah, I'm still having problems. Did anybody else manage to get it?
Anybody has any problem on this one?
Or
Then
did nobody
later
else
on-
try it?
Later on,
Yeah, I'm having issues getting the data as well.
data for here, the same thing.
Yes.
Line. This line doesn't work at all.
I mean, it gives me an error. So I mean, I don't know what's going on.
No, there's no error. This is line. Can you remember? This is, see, no errors.
But isn't that only half of what we need to do?
Huh? No, the
that
other
only
one they
half of
changed.
the
That's what I'm telling. This one they put this one to another folder. Same thing. You don't have to do that one. You don't need this one. You don't have to copy to another folder because we did that one because it's been suggested on that that whatever that document they provided with us. But later on, you get that one and then keep going from here. See, you don't need. If you get the error, I had to check and see why we get the error. See here. See. So normally that from this one, let's say I'm gonna get rid of this one. Okay, get rid of this one and let's try. See, data in, let's say log, no errors. See, error comes mainly this here, data out. Okay, now let's go to data out. Okay, library. I'm gonna go to the library. We already earlier had that one. See, it's already there. So take this out, the data name. Just simply say come from. You're gonna go from this folder to the other folder. That's it. But you don't have to. That's what I'm telling that. From once you give the folder name and then with this command, it's going to convert this XPT data into SAS data. It's done, already done here. See, done. Anytime you can go and then extract data from this guy, this folder, then this folder. But even over here, see what I did, I'm going to convert that into another folder. See, home, this one, my shared link. See, that's the folder. See, data out up to here. See, up to here. This one is my folder. See, that's a directory. That's the library. That's, see, that one now we're gonna put to this one. This library. Earlier, this library, this is a path, and this is the data. When I copy, I took the data out. Data out. Then, oh, I'm sorry. Then see, invalid character present in the data again. Which one was that? Let me see. I'm gonna run this one more time. Is that the case?
I was able to get it after changing the out just to data out.
Data analytics. No, yeah, I think, yeah, see. Now, if you go to the log, I don't see any error messages. See? No errors, everything good. And then you go to transport, instead of go to transport, now you go to data out. I'm sorry, because it's in data out now. Data out, okay. Data out and work with that one, with the contents. Still have that one. Let me see why is that. Characters are present in the data. What is the invalid characters? Okay, are there any missing data? That's what they say. Let me check. No. Where is that document? That the one? No. This one, this one. I think this one. No, not this one. Should be. Should be. It's in the class. Where is the class or class one? On the SAS, no. Not here. Let me check. It says categorical data, KDD classification, contingency table. No, I have to get that. Okay, let me see. Let's get that. Yeah, somewhere should be case study example. This one. Oh, this one. So good. Good. Okay, works. See. Data out, procedure content. But we get the contents. No, we get the content still with the. No, it's early, it works. Can you remember 3000? Something came early. Something is missing over here. Code. So what's going to happen for the contents? We don't see that number of observation this time. See? Okay. Observation missing. So if you go to the way from the contents, if you run, no data out. Let's do this together. You see, then you get this one. But it come along with this invalid characters in the data. An error occurred while processing text data. You know, see that expecting a name 22,322. The option is not recognized and will be ignored. That's why, yeah, we have to analyze that data, what the problem is. But anyhow, that okay, tomorrow when we go through this homework and everything, we're gonna looking into at the same time. We can have a look at it. See, so when you put like this, they're gonna show this one. See, if I take that out, let's say that here Take out and run this one. What's gonna happen? Yeah, still okay. Okay. So let me work with the data out, but the log still have this one. Some being ignored. Yeah, that's why we have to look into that one. See? Yeah, that's mainly that here. At least. So do you guys have any question on that? Getting this one in now? Can you get that one? Can we import that one? Anybody has any?
Yeah, I'm still struggling with it. Maybe we
Struggling
can.
with that one? You don't get that one at all? At least that this step, this one doesn't work. I'm gonna go to this library. See? It's in this transport library. See? Later on, we change that one to we put it into the other library. Home, this number, my shared links. These are that number again. Then the server number. See?
I guess this is going to be one of those where I'm gonna have to play around with it or something like that.
Okay.
Are you going to start it? Can you start a class Slack so we can, or do you do Slack so we can have group communications?
Like, oh,
Hey, Phil, one of the other classmates created a Discord if you're interested in that.
Yes, absolutely. Can you invite me?
If you scroll up in the chat, it's Todd Prout. He created Discord. He's got the link.
There is a link down.
yeah, here.
I see.
Then let's see. So this one, if I see, so, see. Look at this one. Okay, if you want to find this sensitivity here, if you get back to that discussion, so you have to see this conditional one. See, this joint should be divided by this one. See, marginal. See, so it's gonna be how much? See, 20. 20. See, joint would be 20. The PD would be 30. See, 20 over 30. See, 20 over 30. See, 2/3. See, sensitivity third. Similar way that if you want to find that specificity, that means this one, 1820 divided by 2000. See, this divided by that. See, that's the same thing. If you can write that one negative, given that this person is, but the specificity means specificity for this number city, the probability you're going to get negative results. He's not healthy. See, he's healthy. Probability d bar and negative over probability of d bar. So d bar, this is a joint one. Is the one that in that conditions iterable that number. See, 1820 divided by p d bar 2000. Like that. See? Specificity, you can calculate that like that. See. So on the other hand, that the way that we were talking about here, that in order to check that if you go to this one, see this related to the same kind of like a same table that other things you can find it too related to that one. So other conditional, sorry, here this one. Then you need that size, size and power, everything. See, this is power. See, sensitivity is power, power of the test. See, power of the test, sensitivity. And on the other hand, if you need the size, you're gonna get this one, 180 divided by 2000. And if you need like a type 2 error rate, you get the 10 divided by 30, like that. Okay. And in addition to that one, that there are so many other concepts being built up for this one. So many. See, true positive, true false positive. See, this is the same thing being given in the like a this tree diagram. It's a marginal, it's a conditional, it's a joint. Let's go the other way around. Disease person has been identified as a positive. See, disease D bar, positive, negative, positive, negative. See, deceased been identified as positive. Disease been identified as nothing. See, negative. D bar, negative. This is a right decision, but the wrong. Type 1, type 2 error based on that one. See, false negative rate. Type 2 error, type 1 error, false positive rate. See, false positive rate is type 1 error through a tree diagram. Sensitivity, see, it's the same way. See, as a percentage, you can build up this one from the tree diagram. And the power of test, sensitivity, we talk about that one. See, specificity, size, type 1 error. See, these are, we already talk about that. And then positive predictive value. It's a probability that a subject has a disease given that the subject has a positive screening test like that. So many things we can talk about that one too. But mainly that, and then the odds ratio, risk, see, false omissions, positive likelihood ratio, negative likelihood ratio, incidence of a disease, see, prevalence. Prevalence means persons likely to having the disease, PD, simply PD. Incidence, person's probability of being diagnosed with the disease, PT. T means P positive. See? Incidence, prevalence, see? Those things. Sensitivity index. See? Later on, those being then come to the heavy setup. Now here you have to understand one thing very clearly in this discussion. All discussion in this contingency table very easy, piece of cake for a certain reason, because these are based on sample. These are based on sample. This is counterpart you never take into account. It's very heavy. This counterpart means like a population, because you are not talking about just like a sample. You are trying to get the sample, pick the sample. With the sample, you can make inferences about the population. In order to do the population, sometimes we believe that this biomarkers result, see, this is called the dichotomous. This may be dichotomous, this may be discrete. Discrete means like many of options instead of two. Later on, this might can have two, means he's a dichotomous. Then you can go to the discrete one. Discrete means like more than two options for this one. See, then we can see that these two options can we fit into a very certain distribution. They're gonna say that you are that the biomarker, based on the biomarker may be like a distributed according to normal distribution, exponential distribution, but different kind of distribution. That discussion, we don't bring it up over here. We just on the surface, we like just touch something a little bit here in this class. There's no broader that discussion here, but simply we're gonna get like a contingency table based on the data and work on it. It's not enough, because that when you get this answer should be applied to a whole that population whose characteristics being studied at the end of the day. Okay.
Excuse me, Professor. Quick question. I was wondering, since we've gone over a little bit, class. I was wondering if I could speak to some of my classmates before you ended the class, because there's like a little bit of scheduling issues that I wanted to talk to them about.
Yeah.
Several of them are in the same class as me, the entire course, and we're trying to stay in the same course. That's why.
What happened?
I'm trying to make sure that we're all in the same class all the way to graduation. So, and there was some scheduling changes that just happened. So I was gonna talk to them about it.
Oh, okay. You want to talk to me about that one?
No, about to my classmates.
Oh, okay. Sure. Yeah.
Just whenever you're done with class. But I do want to mention that we have gone over quite a bit.
Yeah. So we can, yeah, you can talk to them, yeah, about that one. Okay. So see the precision of that one. See, those things will be even taken into account. Okay. But here they see, here in this discussion, they built up this. See, that's the same thing. That's the same thing instead of that one. That the same thing that we talked about earlier, the drug and placebo, and the negative here that we're gonna treatment, and this negative results, positive results. See, drug, positive, negative. See, placebo like that. Then later on, we're gonna see is there any that whether this the analytical question is whether the new drug was effective, had a positive outcome in treating acne among these 150 study participants. Even a plot of the data suggests that there is indeed an association between receiving the new drug having a positive outcome. See, 60% who received the drug had a positive outcome versus 33% who received the placebo. So we can look into that one, but would that enough for us to make a conclusion at the end of the day? It's not enough. That's why by simply looking at this table, you cannot make a conclusion. In order to make a conclusion, you really need a test statistic. That test statistic would be the chi-squared, okay? Chi-squared. This test statistics would be the chi-squared. This chi-squared will be taken into account to make a conclusion at the end of the day. That's a Pearson chi-squared. That's one of the tests. There are many other tests that when you run this one, see chi-squared CV, degrees of freedom, alpha. This alpha we mentioned at a certain point. Now you know that when you see alpha, when you run this one on a SAS one, here you have to understand this one. There are no that much you have to run on SAS in this course. Only one line, 2 lines. That's it. There are no heavy codes. That's why you have to build up the knowledge over here. That's the key part. Because if you go ahead and look at that SAS, the code is like either 1 line, 2 lines. See, these are like not that much heavy ones. See, look at the procedure, always the frequency. See? Tables. Table means that they are generating this contingency table only. See, this when it comes to the SAS part, it's not heavy. The very basic stuff being utilized, but the contents behind that one is the key part. So what we're gonna do that when we go through that homework, that mainly that if you pull out the homework, see, you saw the homework that already. So the homework, we can see that how that can be set up to go along with that one by during this tomorrow and then even Thursday, because this whole discussion, you cannot stand alone and then discuss anything if they were already connected. So look at that in the homework a little bit. If you have a look at this homework real quick before I'm going to go ahead and stop, okay, for today.
Can I speak to my classmates now then?
Yeah, go ahead. You can talk. Yeah.
All right. So for some of you guys, I mentioned that in order to take all your classes in order, you had to take 630 last and then start your specialization courses starting next class. I just got an email from my advisor saying that there was a bunch of scheduling changes due to, I don't know why, but apparently now she changed my courses. I'm taking 630 next class and then specialization. So apparently you don't need to take 630 last now. You can take it as the next course and still do your specialization and capstones all in order. I just wanted to say that because I know I spoke to several of you offline about changing your courses so that way we could stay in the same ones. I apologize if you did that because now you might have to undo it because I am in 630 as my next class and then the specialization courses. That's all I wanted to say. Did I screw anybody over? Is kind of what I'm trying to figure out.
I got my class changed to 6:50 after this one. But yeah, I'll speak to my advisor and see what she's saying about this. Thanks for the update, Adam.
No problem.
Look at this one, like a little bit we can see. Have a look at this one, see. You get the raw variable, raw data, same thing coming from that, see, BMI data, see. You have to change to, see, BMI for cat to BMI. This one sex to not sex here, this should be gender, okay? Change this one to gender, diabetes 2 to diabetes. Earlier you have a 0, 1 level that here early in the beginning, say male one is 1 and 2, 1 and 2 has been changed to 0 and 1. And diabetes, see, change the variable names, see, exercise any day, see, to exercise like that with the like options being changed. Then see, then you're gonna start the same using proc create the 2x2 contingent table. This by that, not by sex, it should be gender here too. When we go through this homework tomorrow, you can see that mainly that because of Wednesdays, we can go through that one again with the Thursday. We can that broaden up and then enlighten more and then add more flavor to that one and then discuss because anything behind that. See, what is your null hypothesis? What's the significance level you are assuming? What's the critical chi-square value? What is the conclusion from your statistical test? See, you have to write sometimes your null hypothesis. Okay, those things not going to be come along with that when you run the SAS. Okay, significance level that we talk about the significance level. That's the size of the test. How much size you have allocated for the test. That's the size. That means probability of making a reject H0 when H0 is true. H0 is true.
Professor, just to interrupt, I actually have to
go ahead. Go ahead.
I have to go, so I apologize for having to leave early.
No, that's okay because I'm gonna stop right now too. A little bit go through this one because this is the one. Yeah, you can go. Okay, we can continue same discussion tomorrow, and then see we can finish this one. I'm gonna help you out to that come up with all the answers and everything. Learn with that theory related to this one. So in that way that you are in a good shape. Okay. So that's what I'm planning to do. So let's do let's meet tomorrow and continue same discussion and then make sure that everything behind that one get a clear cut idea what's going on behind that one. It's important because later on we saw that see this size already over there. See alpha 0.5. See we're going to utilize that one.
When you say tomorrow, do you mean Friday? The class courses Tuesdays and Fridays.
No, we have our office hours tomorrow, Wednesday.
Oh, okay.
During the office hours, I plan to go through all the answers, but if you miss that one, doesn't matter because I'm going to record and make that one available, okay? So in that way, you're not going to miss anything. Don't worry about anything. Pretty much what I'm trying to do.
Is it the same Zoom meeting link?
Yeah, no, I'm going to send another link tomorrow and then all that announcement and everything in that way that you're not going to miss anything, okay? I'm going to update everything, send a new link, okay? Everything's new tomorrow. And pretty much the same time that even though I said that 1 hour, maybe 1 and 2 hours, 2 or 3 hours, doesn't matter. We can finish this one tomorrow. And then we continue that same discussion because related to this, the discussion, there are so many things being involved because that sometimes that when you get the printout, that printout has a more than what you see. See, you have to know what do you mean by the chi-square CV, degrees of freedom, alpha, and keep going down and more. See this one, see likelihood ratio chi-square, continue to adjustment, Mantle, Highness, that chi-square, phi coefficient, contingency coefficient, Kramer's one. You cannot simply produce a table only. It doesn't work like that way. Later on that you are in deep trouble because if somebody asks a question that where this coming, we have to go through this one, not in detail, like a little bit like the way that I'm doing over here, just a simply little bit, you have to go through everything. In that way, it's a complete discussion. See why they are left-sided, right-sided. It's important because somebody asked, how could we gonna answer that one? See, they were already there, but we get a rough idea. we're not gonna memorize anything. You don't have to, but get a rough idea what's going on behind that one. See? We can go through that one too. That's why I lay down like a kind of a foundation for us to that built up discussion and then move forward. Okay. So the mainly we focus on that doing this in class. Then in addition to that one, in class one, sorry, I'm gonna show you real quick that one in class one. I think you already saw that one. See, in class some questions that we can go through this one too at the same time. See, all these questions too. Okay. And then we continue same discussion even on Friday and keep going. Okay, because we don't have that much of time. Okay. But if you have any question that you can, if you want to have a one-on-one that session to that get clarified anything, you can have that one. Plus that email me anytime. Okay. Okay. Do you guys have any questions? See, before I'm gonna wind up over here for today. If
No, you
not,
said you're gonna go through the, homework tomorrow, but did you say, I don't know if I heard you correctly, did you say that the homework assignment, like the actual file is longer than what it should be, or I don't know if I heard that correctly.
no. These are in-class exercises. There are two types in-class
Oh,
exercises.
okay. I see.
No,
I see.
not
Okay.
this one. The one that I showed you earlier. Oh, you saw that one. I'm gonna show you one.
Yeah,
more.
yeah, I saw it.
Yeah, this one is the assignment one. Okay, this is the assignment one. I'm gonna go through this one as well as the other one with time permit. Then if we don't have enough time, let's move on to Friday and continue. See, we keep continuing that our discussion. Okay. And on the other hand, one more thing that I have not tell you, that don't worry about the deadlines of that your homework. Okay. We'll take your time, make sure that you do everything and then turn into me everything. Okay. But by any chance, if you want to finish it early and you can turn in any time. But if you don't have a time and then you don't have to that restrict to that deadline. I want you to turn in pretty much everything before end of this term. And the last week, right after the final week, I'm going to give another one more week to finish everything too as well. So you have almost like a 5 weeks to finish all the homework, project, presentation, and everything. And in that way, we're going to talk about the project too. I'm going to help you out to that, the lay down a good foundation on the project as well. In that way, because I heavily do research in that way, that you are in a good shape at the end of the day. Okay. So I'm gonna let you guys go and then have a good night. See you tomorrow. Okay. Take care. Bye-bye. Good night.
Thank you, Professor. Have a good
Thank
night.
you very much. Have a good night. Take care. Bye.